Welcome back. This is our second lecture on work, energy, and power. So in the last lecture we talked about work, and this one, work and power, and this one we're going to look at energy. So you can see we've got four equations. This one you've seen before in Newton's laws when we were talking about the springs. Here's a new one, kinetic energy equals 1/2 mv squared, and you can see we got mass, velocity, kinetic energy. Some books will just use a K. I like the KE, it's a little bit more descriptive. This is joules. Had a little typo right here, so that's lowercase kinetic kilograms, so that's no big deal. Velocities in meters per second. And here's PE, potential energy. Some books you might see, like I said, have a U sub G, which is gravity, since remember this is going up and down, potential energy. Oh, we've got G in there, so that tells you we're in a vertical motion. Or E sub P, I've seen them all. Just be careful and use what your teacher tells you. M, G, H, okay, there's mass, G, there's nothing new in height. So we're dealing with vertical motion here, okay? And here's one with springs, potential energy of a spring, which is 1/2 kx squared. Spring constant we've seen. Distance, yes, distance is dx. It depends on how you look at it. And these are things that the physics people are still debating on. So you can probably think, oh, I've seen joules before. Yes, that's our work equation. And just think, what is the definition of energy? It's the ability to do work. And what do you need to do work? Energy. So there's that circular definition that your English teachers kind of try to stay away from, but we kind of do this in the physics part. So let's kind of look at some example problems. So it says, how much energy does a 40, so there's mass, and you know we're traveling at 20 meters per second, so so there's our V, and so KE equals 1/2 mv squared, and it says energy, and I didn't tell you which one was kinetic or potential, but it's moving, so therefore it had to be kinetic energy, and that's the reason why we're using this equation right here. So kinetic energy equals 1/2, and the mass is 40 and 20, and do not forget the little square, and kinetic energy is in joules, and make sure that your J is nice and neatly printed. Here's another one, the object. Okay, now we know this one, we know the kinetic energy. Okay, so I'd give it to you. And it's traveling, so there's our V, and it says, what is the mass? So K equals 1/2 mv squared, and so that's 45,000. And it says it wants the mass, and 450, and don't forget the little square here, and so the unknown is M, and that's in kilograms. So there's a couple of them on kinetic energy. Here's one, potential energy. I'm going to, does it have, in other words, I put it up on a shelf. What's the potential energy? Now with potential energy, there's your mass, there's H since we're above it. With potential energy, you have to usually deal with a reference point, and most of the time we're going to use the surface of the Earth as a reference point, but in some problems they may use a different reference point. Just be able to watch that. So it's mgh, so that's potential energy equals M, which is 100, G is 10 or 9.8 depending on what your teacher wants you to have, and that's 3.5. So potential energy is in joules. Make sure that's a nice clear J. That's pretty much, and if you think about it, let's see. mg we know is a force. Oh, that's a distance, or d. And so what do we have to do to lift up? We had to do work, which is Fd. So that's where this work energy equation comes in. And let's kind of skip over here. Okay, I've got a car traveling at, got a mass, there's kilograms at a v. And I want to know how much work does it take to stop it. And you're thinking, I do not have an equation to do work. But remember, work, what's the units for work? Joules. It's moving. It has kinetic energy. What are the units of each? Joules. They're equal. So to find the work, all I have to do is just do the kinetic energy, find the net kinetic energy to stop it. So my different velocities, I'm going from 10 to 0. So that's 1/2. And don't forget the square. And the work is in joules. Now, you notice if there's no time frame, and work does not have a time frame. So if you push a box and it takes you 5 minutes to push it a certain distance, and somebody pushes the same box and it takes them 20 seconds to do it, y'all done the same amount of work. Think about it, because there's no time frame in work. It's just the power that is involved. Okay, here's one. Here's work to lift. There's our force, and we want to know how high it is. And you can think I can do F is equal W equals FD cosine theta, which I'm lifting. But since this is the energy one, W equals since we lifted it, we got the potential energy. So that's a bad thing about a pen. If you make a mistake, it's kind of hard to erase. And okay, you notice there's no mass, but remember, mg is a force. So we can kind of combine these two to go here. Make sure I got them, let's see, 1, 2, 3, 4 zeros. I want to know how high, and the height is in meters. Okay, let's kind of quickly go to the other side and talk about springs. Okay, it says the potential energy. So now when you see a spring potential energy, you only have one equation to deal with. There we go, now you can see it. Potential energy is equal to 1/2 kx squared, okay? I am looking for the potential energy. And you're thinking, I do not have K. Well, just remember that K is your spring constant, which is a force. So K is equal to F over X. So we can look, so that's 450 over 0.35. So there's how we found the spring constant. You may just have it over to the side, or I'm just putting it in the middle. And then I stretched it. Now I know the spring constant right here. And there's the square again, so don't forget that. And potential energy is in joules, of course. Here's one kind of going with the same way. It says work. Remember, work, energy, the same, so you can use this. And I'm just going to get you, so work equals potential energy equals 1/2 kx squared, and then you can plug and chug. Just one more, just in case this happens, and remember the one we had with the kinetic energy, we're going from 10 to 0, no big deal. But on this one, what if I decrease, I have two velocities, or speeds, or however you want to say it. I know work is equal to the kinetic energy equals 1/2 mv squared. Well, you're probably thinking I can just subtract the two and go from there, but remember, you've got to take the kinetic energy of each one, okay, mass is not going to change. And so I'm going 3.5 squared minus, in other words, you're kind of combining the two problems, to 2.5 squared. So remember that, that you have to square each of your velocities in doing something like this one. Now, if you just had one, zero's not going, it's not going to affect it. But if you do this, you got to square each one, and don't forget to square it, or you're going to have a really messed up answer, to say the least. Well, that's pretty much it for this part. Did most of them for you. Enjoy doing the rest of them. Remember, if you have any questions, don't hesitate to contact me.